Welcome to AmeenAcademy.com. In differentiation, let us discuss about curvature and radius of curvature. The curvature is the amount by which a curve deviates from being a straight line or surface deviates from being a plane. For curves, the canonical example is that of a circle which has a curvature equal to the reciprocal of its radius. Smaller circles bend more sharply and hence have higher curvature. Also, a curvature is a numerical measure of the bending of the curve. At a particular point on the curve, a tangent can be drawn. Let this line makes an angle with the positive x-axis, angle psi, with x-axis. The curvature is defined as the magnitude of the rate of change of with respect to the arc length s. The curvature at point P will calculate it here. Also, the radius of curvature is the reciprocal of curvature and it's denoted by rho. Now we'll derive a formula for radius of curvature. Look at this figure. Here in the xy axis a curve f of x is drawn, and that note the point M and M1 with smaller distance delta s. Now draw a tangent from the point M and M1. Let us these are the two tangents. Let us make these two tangents make an angle of delta psi. Now here the angle psi makes the first tangent and psi plus delta psi makes the second angle to the at the point M1. Now the function that is a given curve equal y equal f of x. We know that the slope m equal dy by dx. Let it be 1. Now differentiate with respect to x further. We'll get first we know that dy by dx equal to tan psi here. Now further differentiating with respect to x, we'll have d square y by dx square, which is equal tan psi. Differentiation is secant square psi and the derivative of psi is d psi with respect to ds. d psi with respect to dx. Now further we'll write this one, that is d square y by dx square can be written as, that is written as secant square psi. Here d psi by dx can be written as d psi by ds and ds by dx. Here further, which is equal secant square psi d psi by ds, and we know that ds by dx is 1 plus dy by dx the whole square. Now further we will write secant square psi. Here secant square, not secant square psi, here first d square y by dx square can be written as, that is equal to, secant square can be written as 1 plus tan square phi into d psi by ds is the reciprocal of the radius of the curvature, which is equal 1 by rho into 1 plus dy by dx the square. Here this square root of 1 plus dy by dx whole square, here also, here d square tan square psi also equal to 1 plus dy by dx the square into 1 by rho into square root of 1 plus dy by dx the square. Now this is, it's not square here. Now square is not here. Square is separate. Here we are having this side square root of 1 plus dy by dx, square root of 1 plus dy by dx whole square. Here 1 plus dy by dx power 1. So 1 plus half is 1 and a half, that is 3 by 2. We can write as this equal 1 plus dy by dx the whole square power 3 by 2 into 1 by rho. But we need radius of curvature, that is 1 by rho, that is rho equal 1 plus dy by dx the square whole power 3 by 2 over d square y over dx square. This is our radius of curvature. We write a center for this rho. Here is a formula for radius of curvature when function is given as y equal to f of x. We have done. Please subscribe our YouTube channel.